Good day, this is Energy Insights Daily. Our lead story, a major milestone in industrial decarbonization and efficiency. China National Nuclear Corporation says the world's first commercial supercritical carbon dioxide power generator has started operations in Guizhou province. The project, called Chaodin 1, is located in Lipanshui, Guizhou, and is now grid-connected to generate electricity from waste heat at a steel production facility. Each unit has a 15-megawatt generation capacity. CNNC says the system addresses a long-standing bottleneck, converting small to medium-scale thermal energy sources into useful electricity more efficiently. So what makes this different? Instead of using steam like conventional thermal power systems, Chaodin 1 uses carbon dioxide as the working fluid to transfer heat and drive the power cycle. The key is supercritical CO2. Researchers explain that when CO2 goes above roughly 73 atmospheres and 31 degrees Celsius, it enters a supercritical state, dense like a liquid but flowing more like a gas, helping it store more energy while keeping flow resistance low. CNNC claims a big performance jump compared with traditional centering waste heat steam systems. Overall power generation efficiency up by more than 85%, net electricity generation improved by over 50%, and required floor space reduced by 50%. The operator estimates the project can generate over 70 million kilowatt-hours per year, adding around 30 million yuan in annual revenue. And importantly for operations, the team says the design is simplified with fewer components, making operation and maintenance easier, and the cycle can react faster than traditional systems. This is a reminder that the energy transition isn't only wind, solar, and EVs. Industrial efficiency is one of the fastest ways to cut emissions. CNNC says supercritical CO2 power generation can support China's dual carbon goals by converting industrial waste heat into power more efficiently. On the timeline, the Nuclear Power Institute of China began research on this supercritical CO2 power conversion technology back in 2009, and construction of the demonstration project in Lipanshui began in 2023. Looking ahead, CNNC also points to a separate demonstration project integrating molten salt energy storage with supercritical CO2 power generation, with demonstration operations targeted for 2028 and potential expansion into solar thermal, energy storage, and broader waste heat recovery applications. The news lands as China expects electricity consumption to hit new highs. China daily cites projections of total power use surpassing 10 trillion kilowatt-hours nationwide, driven partly by high-tech and advanced manufacturing. The National Energy Administration's leadership also indicated China is set to overfulfill its 2025 target for non-fossil energy to account for 20% of total energy consumption. Bottom line, Chaodin 1 is a notable proof point that next-generation thermodynamic cycles, especially supercritical CO2, may scale into real industrial settings, turning waste heat into grid power. That's today's Energy News Daily. If you want to follow up, I can break down where SCO2 makes the most economic sense: steel, cement, chemicals, or data center heat recovery.